talk. Welcome one and all to Math Thursday. We are here to answer any math questions you might have or just questions about learning and teaching in general. So with our Math Thursday content, we usually tend to stick with like pre-algebra through like algebra 2, maybe some pre-calc. But if you have any questions, pop them in the chat and we will go over them. I know a lot of people took the PSAT this week, so hopefully you did well on that. And I know we've got, well, no, it was the SAT this week, I think, around here. SAT this week, and PSAT is next week, I think. But I know it's kind of testing season for a lot of schools and areas and districts and all of that. So, I'm sure there's a lot of really big questions and things that maybe you never really realized that you didn't know because you don't know what you don't know. But let's just start off with a little function notation. So if f of x equals 2x plus 3, what would be f of 3? Ooh, Taylor, multiplied binomials. So you want to go over just multiplying binomials together and then simplifying? We can do that. Okay, good. Excellent. Okay, so you guys have all got function notation down pretty well, which is awesome. Okay, so function notation, this f just means that it's the function that we call f. The function of x, okay, this function f, what it's going to do to whatever you plug in here, it's going to do times 2 plus 3. So functions are it's sort of like a machine, like they're able to do one thing really well, and in this case, it's able to do times 2 plus 3. So whatever's in this parentheses, okay, whatever's in these parentheses, you just substitute that in for the x. So whatever's there, right, just gets substituted in right there. So in this case, this was 3, right? So 3 goes there. So f of 3 is 2 times 3 plus x, 2 times 3 plus 3. Okay, so 2 times 3 is 6, 6 plus 3 is 9. Excellent. So if this were something like -1, right, it would be 2 times -1 plus 3. So that would be 2 times -1 is -2 plus 3 is 1. Okay, so this is just the basics of function notation. Okay, and I know my students have a quiz over this tomorrow. So I'm sure we'll be going over it later because they usually pop in and join. But this is just kind of a basic of function notation. Okay. But yeah, so whatever's in the parentheses is what you substitute in. Okay. All right, so we had somebody asking, who was that? Taylor, I think it was Taylor was the name, for multiplying binomials. So multiplying binomials, when you've got, well, a binomial is where you have 2 terms. Okay, so this is a binomial and this is a binomial because they each have 2 terms. Now I'm multiplying them together, and there's a few different ways of doing this. Okay, so we've got, when we're multiplying these together, we just want to make sure that both terms in this binomial get multiplied by both terms in here. Okay, so an easy way to keep track of if you are getting everybody multiplying by everybody, right? So we can go, well, let's go like this. So what I could do is I could just say, okay, x times 3x and x times negative 4, right? So x times 3x is 3x squared. Because since I'm multiplying the x's together, I just add those together, right? X times negative 4 is minus 4x. Okay. And then I could look at, and I could multiply the plus 1 by both of those, right? So 1 times 3x is going to give me plus 3x. And 1 times negative 4 is going to give me negative 4. Now, an easy way to remember how to do these is FOIL. Okay. So foiling is an easy way to remember how to, like, kind of, it's almost like a checklist of, like, did I multiply everyone together, right? I will definitely show you the box method, absolutely. Okay, because I actually prefer the box method anyway. So F means first, x times 3x. O means outside, which is x times negative 4. I is inside, which is 1 times 3x. And L means last, which is 1 times negative 4. This is just a way to remember and, like, keep track of, like, multiplying everybody together. Okay, so I see everybody saying about the box method, which I totally agree with you, that FOIL, when you're saying FOIL, it doesn't mean anything, right? Other than, like, when somebody sees those, then they go, oh, you FOIL them together. It's like, well, you can use FOIL to remember that they're being multiplied together, or that everything is being multiplied together, but it only works for 2 terms, right? It doesn't work if you have a trinomial or anything like that. So it's just really a kind of a mnemonic way for multiplying those things together. Now, one more thing that I realized that I forgot to do was that now I would combine these like terms, right? So I would have 3x squared, negative 4x plus 3x gives me negative 1x, and then I would have minus 4, okay? All right, so... yeah, exactly. So Okra, this is a trick. This isn't the concept, right? This is just a trick for remembering how to multiply everything together. Now, the box method is really good, and it's also called an area model, okay? It can also be kind of used in a lot of other applications, right? So one of the applications is, like, if you think about Punnett squares, right? When you're talking about genetic combination or recombination and how these alleles are going to combine, you can use something called a Punnett square. But it's also talking about, like, an array, right? It's all sort of part and parcel of the same thing. So the box method, or the area method, is where, so we've got 2 terms by 2 terms. So I'm going to make a 2 by 2 array. This is going to be too small or not. Okay, so this is 2 by 2. Okay, I'm going to put one of my binomials up there. I'm going to erase the FOIL here, actually. Okay, so for multiplying these together, okay, I'm going to draw this a little bit bigger. So again, this is a little bit clearer way of showing what you're doing, right? Where you're actually multiplying these together, okay? So I'm going to take one of my binomials and I'm going to put that up here. So I have x and plus 1, okay? So x is going to go into this column and plus 1 is going to go into this column, okay? And now 3x is going to go over here, and minus 4 is going to go here. Okay, so I have x plus 1 and 3x minus 4. So 3x is going to go across here, minus 4 is going to go across here. Now what I'm going to do is we're going to take these and we're going to multiply them together. So just like in the times tables, right? The multiplication tables. So I've got 3x times x, which gives me 3x squared. 3x times 1 gives me 3x. Okay, and if I don't have a symbol there, it means it's positive, right? Then I have negative 4 times x, so it gives me minus 4x. And I have negative 4 times positive 1, which gives me negative 4. Okay, now everything that's in blue is what I'm going to add together to make my result, right? That's going to be my simplified way after I've multiplied these together. So I look for any like terms, like here, 3x and minus 4x, okay? And I'm going to add those together. Okay, so I've got 3x squared. 3x minus 4x gives me minus 1x, and then minus 4. That demonstrates the concept, right? We were talking about trick versus concept, right? So in this case, when I use this area model or this box method, I can use that, okay? I can use that to make sure that everybody gets multiplied together. Okay, so this, yeah, so negative 4 and 1, it's not negative 4 plus 1, it's negative 4 times 1. Okay, so these are all multiplication in here, just like a times tables. You can absolutely do it with a trinomial, okay? And I will show completing a square like that, okay? All right, so Taylor, let's first look at it with a trinomial, okay? So if I'm multiplying two things together, like let's say 2x minus 1 times 3x squared plus 4x minus 5. Okay, so now I'm going to draw another array like this, right? I'm going to draw another grid, okay? If you guys go over, so Alex and TD, if you go over to YouTube, you can rewind. I just did FOIL not long ago. And what we talked about was that FOIL is just like an acronym to remember, and it only works for when you have 2 by 2. But when you're multiplying these together, I'm going to show you how you can use the box method to multiply these together, right? Okay. So we've got 2 terms here, and we've got 3 terms here. So instead of having a 2 by 2 box, we're going to make a 2 by 3. Okay. And it doesn't matter if it's 2 by 3 or 3 by 2. The direction doesn't really matter. As long as you keep one of the terms, one of the nomials on one side and the other down the other side. So I'm going to make this 3 across the top and 2 down the side. And this also works really well for factoring too, as you can kind of work backwards for that. Okay. Okay. So let's do 2x and minus 1 down here, and 3x squared plus 4x minus 5. Okay. And we're going to fill these in. Remember, we're multiplying to fill all of these in, right? Okay, so I've got 2x times 3x squared, which gives me 6x cubed. And then I've got negative 1 times 3x squared, which is negative 3x squared. Moving on, 2x times 4x gives me 8x squared. Negative 1 times 4x gives me negative 4x. And then 2x times negative 5 gives me negative 10x. Negative 5 times negative 1 gives me plus 5. Okay. So again, I'm going to add the like terms, right? 6x cubed, that's the only one that has an x cubed. So that's going to be by itself. Then I look here and I've got 8x squared minus 3x squared, which gives me plus 5x squared, right? Because now I'm going to be adding all of these together. So to get to get what goes in each box, I multiplied, but then when I'm coming up with my final answer, I'm adding them together. So negative 10x minus 4x is minus 14x. And then 5 is the only number, so I have plus 5. So there we go. It works with any number of terms, right? You could do like 4 by 4 or whatever, right? And it works in a lot of other contexts, okay? So when we do, good, Taylor, I'm glad that that helped, okay? So when we're looking at these, okay, if you're working with a quadratic, okay, and you're trying to factor a quadratic, okay, so factoring means basically you're going from this back to this, okay, or from this trinomial back to these two binomials, okay? So that's what you would be looking for if you were factoring, okay? So factoring a quadratic like 2x squared plus, let's see, we'll put 8 down here. And let's do, actually, I'm going to do 5 here and then 11x here, okay? So if I needed to factor this, which is something that a lot of you need to do, so factoring, you can use the area model for that as well. Now, it doesn't get you away from like having to sort of figure out what multiplies to this and adds to this, but it is a nice way to sort this out. Okay. You can definitely use the quadratic formula, but a lot of time, all right, God loves you. Synthetic division is on my list. Okay, so 2x squared plus 11x plus 5. So what I do is I need to take this term, this 2, multiply it by 5, okay? So 2 times 5 is going to give me 10. Now what I'm going to do is I'm going to look for factors of 10 that or two numbers that multiply to 10 and add to 11. Okay, so I did 2 times 5, which is 10. Now I'm going to think about my factors of 10. Well, I've got 1 and 10, and I've got 2 and 5. 3, no. 4, no. 5, I'm back where I began. So now looking at these, okay, 1 plus 10 can equal 11, right? So now I know that this is going to come from a binomial. So what I can do is I can use the area method or the box method, right? However you want to say it. And I can sort of work backwards. Okay, so I can fill in, I can think back to something like this, right? And now I'm just kind of working my way backwards. Okay, so here, remember, we took these two and we added them together and we got that -1 in the middle, right? So here, these two are going to need to add together to make 11. Okay, and I already figured out which two numbers those are. They're 1 and 10. So I'm going to go ahead and I'm going to fill this in. And I've got my 2x squared. So that goes in this box. My 5 goes down in this box. Okay. My 1 and my 10, I'm going to split those. And it doesn't actually matter. I'm going to just write plus 1x in here. I know you don't have to write the plus or the 1, but we're just going to do it for now, right? And then this one's going to be plus 10x. So now, again, we're kind of working backwards, right? So I'm going to look at the columns and I'm going to look at the rows and I'm going to pull out the greatest common factor out of there, okay? So 2x squared and 10x, they are both divisible by 2x, okay? So I'm going to take out 2x, okay? So they're both divisible by 2x, so I'm going to put that up there. Now over here, I've got 1x and I've got 5. There's no greatest common factor, so I can always take out a 1. And if they were negative, I could take out a -1. I mean, I can take out a -1 no matter what. But I can always take out a 1 or a -1. It's just going to flip the signs, okay? So now I'm going to look at the rows, okay? I'm going to switch up the colors for this. So looking at the rows, I've got 2x squared plus 1x. So the only thing that they're both divisible by is x. Right? So the greatest common factor really just means the largest number or value that they're able to both be divisible by. or divided by. Okay, so 10x and 5, the greatest thing that they are both divisible by is positive 5. These are my two binomials right there. Okay, so I've got 2x plus 1 and x plus 5. So those would be my two binomials that when I multiply them together, they are going to equal this 2x squared plus 11x plus 5. Because you've got all the work here, right? We can go from here all the way through to there, or I can go from here all the way through back to there, right? So that is factoring a quadratic using the area method or using the box method, okay? All right, so somebody asked for completing the square with the area model, and then we'll get into synthetic division of polynomials, okay? So completing the square with the area model is, I mean, it's literally completing a square, okay? So if I have a square, if I'm looking for, okay. So if I've got x squared plus 6x plus k. Okay. We're going to say, what's the value of k that makes this a perfect square? You know, there's a reason you would want to find a perfect square, and that's because when you're getting into solving quadratics and things like that, it's really helpful. Okay. Now, a perfect square trinomial, or a perfect square well, no, it is a perfect square trinomial, is where half of this number squared is this number. So half of 6 is 3. 3 squared is 9, right? So this would be written as x plus 3 squared if k equals 9. Okay, so if k equals 9, then I can write this as x plus 3 squared. Now, the reason we call it completing the square is because if we know that this is going to be, if half of 6 is 3, right, we know that this is going to be x plus 3, and this is going to be x plus 3, right? But if we still don't know what k is, we're kind of looking for what this value would need to be, right? So x squared, and we've got 3x here and 3x here, and this part here is the value that completes the square. So your k value completes the square. So when you're learning how to solve and like solving quadratics by completing the square, you're literally completing the square. Like you're literally trying to figure out, okay, well, if this is a perfect square, what does that value have to be? And then you just like force it to be that. And then you can solve it in a really easy way. It's pretty cool, right? Math Punnett squares are totally wild, okay? They're just arrays. They're just arrays. They're times tables. They're all over the place, right? So that is where, when you're trying to figure out this k value, you are actually trying to complete the square because you know what this x plus 3, because half of 6 is 3, okay? So this question was just, we were talking about using area models for factoring and for multiplying binomials. But so then somebody asked about completing the square, so that's where we are. Thank you. That is such a fascinating thing, and I am sure that one of my high school teachers told me what completing the square was, but it just never fully clicked to me until I had to start teaching it, really. A lot of this stuff, you never really know. You may not fully understand something until you have to teach it. Like that's when you really start understanding where it's coming from. Yeah, so that's just something that's so interesting where it's like completing the square. Because So putting it into a little bit more context, if I had a problem like this, like if I had x squared plus 6x plus 2 equals 29. Okay, and I go, you know, looking at that, if that were 9, it would be a perfect square trinomial. So why not just make it a perfect square trinomial? You can add 7 to that, right? Just add 7 to it. Now, you can't just add 7 to one side and not do it to the other, right? If I add 7 there, which does make it, right, it completes the square, right? It fills in that square. That makes it x squared plus 6x plus 9, but I can't just do that on one side. I've got to do it over here. Now, the beauty of this problem design is that I made it this way, right? So now I've got a perfect square on both sides. So x squared plus 6x plus 9. So I can rewrite that as x plus 3 squared equals 36. And now that I have completed the square, I can take the square root of both sides. So now I have that x plus 3 equals plus or minus the square root of 36, which is 6. Okay. So then you can go from there and you can do, all right, so x plus 3 equals 6, or x plus 3 equals negative 6. So x equals negative 9, or x equals 3. So those would be my solutions. And it's all because up here, I completed the square, right? So this step right here is completing the square. Okay, x equals 3 or negative 9, yep. Okay, yeah, okay. So, synthetic division. All right. Put these off to the side. Oh, I love drawing that picture of completing the square. It is so cool. Okay. Okay. Let's see. Synthetic division. All right. So synthetic division is when you are, let's see, synthetic division is so fun. Chart with x and y, and you have to decide if it is linear or the other two types. Lily, so I teach primarily 10th grade right now. That's the primary grade that I teach, but I also have a class of juniors, and I've taught a lot of different grades. Okay, so synthetic division, let's see. So this one, we've got x cubed minus 2x squared. Oh, this might have been the same one that I did a couple weeks ago. That's okay. Plus 6 divided by x minus 3. Okay. So there's a few different applications that you might use this. I usually use this, or I often use this with my students when we're doing polynomials and finding the roots of polynomials, because if you know one of the rational roots, one of the real rational roots, you can then divide the polynomial equation by that rational root to get the other roots, maybe the irrational roots or something like that. Okay, let's see. Okay. All right, so here we go. So synthetic division. Synthetic division is sort of a, not really a shortcut, but it's sort of like a shorthand way of doing long division, okay? So it's where you're really just paying attention to the coefficients and how they interact with this value, okay? So when we set this up, so the way that we set this up is we just kind of set up this little grid like this, okay? Now this x minus 3, I'm going to actually flip that value and I'm going to use positive 3. Okay, so the reason this 3 is out here is because this is a negative 3. So I use kind of the opposite of that, okay? Now in here, I'm going to list all of my coefficients from here. So this first coefficient is 1. The second one is negative 2. The third one is negative 5. And that last one is 6. Now I'm going to make I like to make a little box down here. It just kind of helps me stay organized. And that box is if there's a remainder. Okay, so going back to like when you had remainders, like back when you were first learning how to do long division, they don't go away. Remainders are still a thing. Okay, so we're just listing the coefficients, and then we've got that it's technically it's the root, right? X minus 3 would be x minus 3 equals 0, right? So what we're going to do first with this, the first step is we bring down this 1. Okay, we bring down that first coefficient and we just write it there. Okay. Now, we're going to do just the same thing over and over. We're going to do this times this and write it here. So 3 times 1, and I write it here. Okay. And then I add. So negative 2 plus 3 gives me 1. Do the same thing. This times this, put it here. 3 times 1 is 3. Add. Negative 5 plus 3 is negative 2. This times this, put it here. 3 times negative 2 is negative 6, and I add. Now 6 plus negative 6 gives me 0, so there is no remainder. Okay. These are my coefficients for my answer, for my solution. Okay. But since I've divided by this, this x minus 3, my first x value, well, so my answer is going to be 1 less degree than what I started with. Since this one has an exponent of a 3, my answer starts with an exponent of 2. Okay, so since this one is 3, I start with 1 less. So my answer is going to be 1x squared plus 1x minus 2. Okay, so that is my solution. Okay, so then I would have x minus 3 times x squared plus x minus 2 would equal this if I multiplied them together. Okay. So what grade do you learn that? I mean, it's definitely an Algebra 2 topic, but you may have seen it earlier. You may see it later. It just kind of depends on what math you are in. Let me see. Rebecca, which one did you write? Oh, for the table of values, so determining what kind of function you've got. Okay. So guys, for those of you who are just joining us, we primarily are focused on like pre-algebra through algebra 2, a little bit into pre-calc, but that's kind of our main focus is pre-algebra through algebra. But if you have a specific calculus, pre-calc, more advanced math question, or any question really, pop it into the chat, because what you can do is there's a lot of really good helpers in this community, and they may be able to kind of like help you out with that if I can't get to it or anything like that, because I've got a lot of chats flowing through. Okay, so Rebecca, with the table of values, so like you're kind of like determining the function from the table of values, right? Okay. Oh, God loves you. I'm sorry. You have a question going back to that. Let me see. Hold on. What do you mean 1 less degree than what you said? So what I mean is that 1 less degree than what I started with. So I started up here with a 3rd degree. So this is x cubed. Okay. So then my answer is going to be 1 less. So this is going to be x squared. Okay, because I'm dividing, so it's going to be a little bit less, right? So we've got x to the 3rd. So my solution is going to start with x squared, or x to the 2 power. Okay, so that's what I meant by like starting with 1 less degree. Okay, hopefully that came out. Okay, good. Yeah, so it's just that sort of thing, because otherwise you're going to run out of numbers, right? You're going to run out of coefficients. But so if you see you have 4 terms here, I only have 3 terms here. So I've got to start with 1 less degree. All right. Okay. Let's see. Yeah, x cubed divided by x is x squared. Yep. Okay. All right. So with a function, so there's a couple of things when you have these x and y values. With a table of values, this might be a little bit hard to kind of demonstrate on here, but what you're looking for is the change between the x and the y values, right? When you first learn how to graph and plot functions and things on the coordinate plane, you learn about slope, right? You primarily focus just on linear functions. So if I've got like 2 and 4, right? 3 and 6 and 4 and 8, right? So when you're looking at these, you've got when x is 2, y is 4. When x is 3, y is 6. When x is 4, y is 8. So what we're looking at is when these steps are all like addition, right? And it's consistent, that's how you know that it is a linear equation. Okay? Because it's a consistent linear increase. Okay? It's just going up 2 over 1, up 2 over 1. Oh, sorry, this all says plus 2. This should say plus 1. Apologies. Plus 1. And then plus 1 again. Okay? So these are proportional, right? So looking at these, so 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So with this one, because I know that this is linear, again, because I'm just adding 2 each time, it's the same amount that I am adding to. Now, if I had something like, that was not a linear increase, not a consistent increase, right? So if I had something like, right? So if this was 2, 3, and 4, right? And this is 4, 8, 16, right? So in this case, what you're looking at is from 4 to 8 is plus 4, but 8 to 16 is not plus 4, right? So the increase is not linear. It's changing each time, right? Even though the x is still plus 1 and plus 1, right? This is no longer plus 2 or plus 4 or anything like that. It is times 2. This is times 2. So when you see that the rate of growth is actually like multiplying as opposed to adding or subtracting, right? If this is multiplying or dividing, this is getting into exponential. Okay, so this one here would be f of x is 2 to the x power. Okay, so that one would be 2 to the x power. Over here, this would be f of x equals 2 times x, okay, because that is linear. Okay. Now, if you were to see something like, let me see. You've got, we'll stick with 2, 3, and 4. Okay. And we would have, like, if this is 3, 2, and 3. Okay. Now, obviously, I'm just picking 3 points, right? Like, picking 3 points out of here, like, it doesn't give you a big picture of it, right? But so this right here, the fact that it went 3 to 2 to 3, if you think about what that three to the x power, no, these are all 2 to the x power. So my x value is going to be my exponent. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. That's what that is. Okay. Yeah. So here, the fact that I have this kind of like, it's going to change and then go back up. So it's getting down and up, right? It goes 3, 2, 3. This is showing you a parabola. Okay, so this is getting into a parabolic, which would be like a quadratic function. Okay, so that's what you would be looking at there, right? Yeah, so this is a linear function. This is a nonlinear function. This is a nonlinear function. Okay, so these types of things would be sort of what you're looking for, right? Is the change in the change in values and how they're kind of going through, right? So writing an equation from a table is for a quadratic. What you can do is, well, so here we go. So for this, we know this is quadratic. Hi, John. You made that clue way too easy that I know it's you, John. But I agree, it's the best song that was ever created. Okay, so here we know this is the vertex, right? So this is the vertex. So the vertex is 3, 2. Okay. Now what we can do is we can use the vertex form. Okay, we can use the vertex form to then plug this in and figure out what it is. Okay. All right, so the vertex form of a quadratic equation is you've got y equals, I always called it A. I'm going to call it A, not Q. I'm not sure if I've ever seen it as Q. It's A times x minus h squared plus k. Okay, now h and k are your vertex coordinates. Okay, the vertex is when you're looking at a quadratic like this, this is the vertex. Okay, or if it's like this, it's like the turn. That's the vertex. It's the lowest or the highest point. Okay, so what I can do is I can plug in my vertex. I plug in everything that I know. Okay, I know my vertex, which is 3 and 2. Okay. Now, I don't know what my A is, but I can figure it out because I also know a point, right? X and Y, if I plug in everything that I know and solve for what I don't know, I can figure out what my A is. And I have no idea what this quadratic is going to look like, guys. I just made these numbers up, so I have no idea what it's going to look like. This might be a total mess. But let's use 4 and 3. Sure. Let's do 4 here, because 4 is X and 3 is Y. Okay. So now I've got 3 equals A times 4 minus 3 is 1 squared plus 2. Ooh, this actually is going to work out okay. Okay, so if I just keep working and solving for A, I've got 3 equals A times 1 plus 2. So my A value equals 1. So now I can plug everything back in to get my, equation with my A value is 1, my H is 3, and my K is 2. So I actually don't need this board. So my equation for this quadratic is, I can use, I'll do f of x equals, A is 1, so I don't need to write that down. So x minus h, which is 3, squared plus 2. So that would be my formula for this quadratic. Okay, so this would be what your quadratic would be based on that table. So again, it's just kind of noticing different things, mainly about the y values are what are really going to show you if it's that type of function. Okay. Okay. Let's see. Okay, good, Rebecca. So that helped. Excellent. Okay. Alex, do you mean so factor each polynomial then solve? Do you mean like factoring a quadratic and solving? Erica, mystery version, just pop it in the chat and see if we can help you out with it. Okay. Ooh, John, yes. Okay, one of the more difficult ones, do you want to do one? So we've been we've been working on operations on polynomials. Okay, that's what we've been working on primarily, which is like operations on functions, not polynomials. So John, are you looking for like one of, well, let's just get into it. So if we do f of x equals 2x plus 1, we do g of x equals x squared minus 4x. Okay, so that probably makes it a little bit, oh good, Florida man Kyle, I'm glad it changed your life. It's a handy little trick. Those percentages are reversible. Okay, so when we've got these two functions, okay, we've got these two functions and we need to, we can combine different functions. So this function notation, I touched on it earlier, but this just means that this f of x, it's not f times x, it's f of x. It's the function that we call f is 2x plus 1. So whatever's in that x spot is what I put in for that 2x plus 1. Whatever's in this x spot, I would replace here with these x's for function g. Okay, so I've got function f and function g. Now I can do a lot of things with these functions. One of the things that I can do is I can combine them into one function. Now, when would you want to do this? There's a lot of different examples, but usually, you know, like real world examples or real world problems don't always fit into like one specific type of function. They are often kind of a combination of a few different ones. So one example that I used in my classroom was, you know, if you are running a business, right? And you've got one function is like how much money you are making in profits, right? The other function is how much money you have spent in, you know, on your different like things like running the business. And so what you're really looking for is overall, like your overall profit, your net profit is going to be a function of the two of those kind of working together, right? So that's when you might need to like combine different functions and things like that, okay? So if we've got, so f of x, let's start really easy, right? F of x plus g of x, okay? Now another way to write this is f plus g of x. Okay. So what I would do with this is I would literally take f of x and add g of x. So I have my f of x, which is 2x plus 1, plus my g of x, which is x squared minus 4x. Okay, combine any like terms. Well, x squared is going to be on its own. 2x minus 4x is minus 2x. And then 1 is 1. So this would be my f plus g of x would be these two just combined together. Okay, pretty straightforward for that. Okay, but now, hey, good night, children. Okay, so if we've got something a little more complicated, right? If you've got something like this, okay? We'll just start with x, okay? So I know it looks like it says fog, right? So fog of x. Oh, somebody said what happened to the 4x? I combined it. The 2x and the minus 4x became that negative 2x. So we combined them together. Okay. So logarithmic functions are a little bit out of our purview for this. So we primarily focus on pre-algebra into like algebra 2. But if you have a specific question about logarithmic functions, you can pop them into the chat and maybe somebody will be able to help you out with that. Okay. So we've got this O, basically it's an O. Okay, it means f of g of x. So this is the same thing as f of g of x. Okay, So what that means is I'm going to take my g of x and I'm going to use that to plug in to my f of x. Okay? So f of g of x, so let's bring this back down. Okay, so we see what our functions are. Okay. So f of g of x I have my f of x, which is 2 times x plus 1. Now notice I left that big open space, okay? Because this is kind of going back to what we talked about at the very beginning of the hour, which was just kind of function notation, okay? So basic function notation is here, okay? I've got my this is 2x plus 1, right? Whatever I put in the parentheses is what goes in here. So if this were 2, I'd put in 2. And I would have 2 times 2 plus 1, which is 5. Okay. Oh yeah, Sean, nothing but the best for markers around here. I'm very particular about my markers. If I had 3 here, I'd put in a 3 here. 2 times 3 plus 1, that's 7. Boop. Okay. If I had a squared here, I'd put in a squared here. Whatever I put in here, oops, uh-oh. There we go. Sorry, I had to do my little validation thing. Okay. So this is called function notation. So whatever I put in here substitutes in here. So this is also, what I could also put in here is g of x. Okay? Now g of x is x squared minus 4x. So what goes in here but x squared minus 4x? Okay? Function notation never changes. This is exactly what it is the whole way through. Whatever's in here, that's my input, and I stick it into my other function. Okay? So now I would go through and I would do 2 times x squared, which is 2x squared, 2 times negative 4x, which is minus 8x, and then plus 1. So I'd simplify it like that. Okay? Let me see. I'm not sure. I can't tell. This doesn't seem to be super easy to read on the screen. I can't tell. But I'll go ahead and go over this in the blue. Okay? So again, whatever's in here substitutes in here. And then you simplify it. Okay? Now what if this were reversed? If I reversed it, if I did g of f of x, the rule doesn't change, right? But it gets a little bit more complicated just because the functions are what they are. So if I did g of f of x, okay? Now, g of x is x squared minus 4x. So I've got 2 spots that I need to substitute in, right? Now I substitute in whatever is in the parentheses. So in this case, I'm substituting in 2x plus 1, right? So I'm gonna just change the color so it's a little bit easier to follow, right? So g of f of x. So g of x is x squared minus 4 times x. Ooh, I think I'll be okay on room. Okay, so remember, whatever goes in here is going to get substituted into both of these, right? So if this were 2, I would have 2 squared minus 4 times 2. Okay, just like we did up here. But in this case, it's f of x that's being substituted in. So f of x is 2x plus 1. So this is going to be 2x plus 1. And this is also going to be 2x plus 1. Nothing changes, right? I'm still, whatever's in here, I'm substituting those in. Okay. Now again, it gets slightly more complicated just because of what the functions are, because now it's not as easy as just like, oh, distribute the 2 and then move on, right? Because now I've got this 2x plus 1 squared. Well, 2x plus 1 squared is 2x plus 1 times 2x plus 1. And then I've got this minus 4 that I need to distribute. So I've got minus 8x minus 4. So this is what I'm going to be simplifying. So I'm going to multiply these together, okay? And we went over a whole lot of stuff with multiplying binomials together, right? So this becomes 4x squared plus 4x plus 1 minus 8x minus 4. Okay, so this 4x squared plus 4x plus 1 just came from the 2x plus 1 times 2x plus 1. And the minus 8x and the minus 4, those all stay the same. So now I'm going to look for my common factors. So I've got 4x squared. Got plus 4x minus 8x, that's minus 4x. Plus 1 minus 4 is minus 3. So g of f of x, in this case, is 4x squared minus 4x minus 3. Okay, so John, I hope that helped you out. Here, I'll actually leave this up for a little bit more. Okay, there we go. All right, so Giovanni Q, let's see. So algebra inequalities. So when we are, all right, John. Those are probably the most complicated ones that are on there for tomorrow. But yeah, everything else looks just like your review sheet. I mean, these were on your review sheet too, so, but still. Okay, so Giovanni, let's do algebra inequalities, and then we'll probably be about out of time, and I'm out of boards. So, algebra inequalities, so when we're looking at algebraic inequalities, we're trying to find, so inequalities are going to be where they're not exactly equal, they're, greater than, less than, greater than or equal to, or less than and equal to, right? So if I have something like 3x plus 4 is less than or equal to 10. Okay, I am going to solve this exactly like an equation. Okay, nothing's going to change. The sign is going to stay the same. I'm going to solve it just like an equation. The only time I flip the sign is if I'm trying to flip the whole thing, right? If I want my x to be over on this side, right? If I'm trying to rewrite the whole thing, or go over road. I don't know what that is. R-O-A-D, I don't know what that is. So you're either going to flip the whole thing where you're like twisting the whole thing around, or you're multiplying or dividing by a negative. Those are the only two times when you'll actually change the sign. So in this case, I'm going to solve it again, just like an equation. Subtract, whoa, I got ahead of myself. Not minus 6, minus 4 from both sides, right? So now I have those go away. So I have 3x is less than or equal to 6. And then I divide by 3 on both sides, and I get that, oh my gosh, yeah, we're going to call it a night because I am. X is less than or equal to 2. Okay, so in order for 3x plus 4 to be less than or equal to 10, x has to be less than or equal to 2. Okay, so that one we didn't have to change the sign or anything like that. So let's look at one where we do. Okay. If I said that 12 is greater than 5, 5x minus 3. Okay. Okay, again, I'm going to solve it just like an equation. I'm just going to go through the steps, right? So I add 3 to both sides, plus 3, plus 3. So I have 15 is greater than 5x. I'm going to divide both sides by 5. And I get 3 is greater than x. Now, when you answer these, okay, usually, typically, your answer is actually going to be flipped. The x is going to be on the left because you want to read it left to right. So you would say x is greater than or equal to 10 or whatever it is, right? So in this case, this is when I would flip the sign because I have to kind of think about flipping a pancake. Okay, I'm going to flip the whole thing at once. Okay, so 3 is greater than x, which means that x is less than 3. Okay, so that is a time when you need to flip the sign. Okay. All right. We're going to do one more inequality, but Braden, I don't usually get into geometric proofs on this channel because they're really hard for me to demonstrate and write them out on these boards and just with the setup. So ultimately, you know, my biggest piece of advice with geometric proofs is to just be as specific and pedantic and detailed as you can be with them. Okay, so thinking about kind of figure out your pathway for solving your problem and then justify each step. That's the best advice that I can give. Okay, so now let's do 10 minus 3x is less than or equal to 4. Yeah. Okay, so 10 minus 3x is less than or equal to 4. So again, solving it just like an equation. Okay, minus 10, minus 10. I've got negative 3x is less than or equal to negative 6. I'm going to divide by negative 3. Now this is another time when I need to flip the sign. Okay. Okay, Braden, glad I could help. So negative 3x divided by 3 is going to give me x. Now, since I divided by a negative, I've got to flip that sign. So I'm just going to change the direction. And then negative 6 over negative 3 is positive 2. So if 10 minus 3x needs to be less than or equal to 4, then x has to be greater than or equal to 2. Okay, so that is kind of looking at algebraic inequalities kind of in a nutshell. Again, the only 2 times you need to flip the sign is if you're multiplying or dividing by a negative number, or if you're flipping it over like a pancake, right? You're flipping over that. Okay. All right. And that is what we've got. Okay, so it is 9 o'clock. If you guys have any other questions, you know, you can find me on all the channels, on all the platforms and everything. Like, follow, subscribe if you are in need of tutoring. We've got a great setup for tutoring online. And yeah, have fun. Keep doing math. Okay.